Peter, I heard your video isn't working. Are you on the audio?
Hey, Bill, can you hear me?
I can, yes.
I am in the future. It's Friday morning here in Australia, and it's beautiful sunshine here. And I was hoping I could show everyone like the background in Sydney, but then I basically logged into the webinar and suddenly realized that my laptop, which is running Chrome OS, isn't supported to present stuff and go to webinars. So this is going to be not only my first talk during a pandemic, but it's also going to be my first talk during a pandemic, doing it from my phone. So that'll be interesting.
That will be, yes. So you're going to talk. I'm going to talk a little bit about DevOps.
I was listening to Mike's talk while I was kind of trying to fix my presentation problems, but I think it was really interesting that Mike was kind of saying that when he talked about XSS, half of the developers kind of blanked and stared and said, "We got no idea." And I think that's one of the things I want to speak about.
This fits in really well with our general theme of automation and working within AppSec in a way that can be accessible by your average everyday InfoSec person. So this is going to work out really nice. My goodness gracious, you have a lot of certifications.
To be honest, Bill, I think they've all expired, and I didn't renew any of them because I was too lazy.
I'll let you get started. Let's see if we can get your slide showing here on the screen. I can change presenter to you. Oh, look at you. Okay, good. All right, we're in good shape here.
Let's see. Let's do play.
This is going to be
So I have to go to landscape. Yes.
I love it.
Can you see that?
I can. I'm going to turn off my video so people can pay attention, and you go, and we'll be here when you're done.
Well, I basically was thinking about what can I use as an initial shot, which is in the theme of Wild West, because I've never been in the Wild West, and which is also related to basically down under Australia. So I kind of photoshopped my face on Crocodile Dundee, but I'm not sure why I have so much lipstick there. But anyways, I want to talk about, hey, stop calling my baby ugly, and why do we need to take a different approach with developers and security? As Jim said, my name is Pieter Danhieux, and I basically I grew up in Europe, in Belgium. They mentioned Brucon, the Hex Factor, and I know there's at least one other Belgian person on this conference, because, hey, Chris, you messaged me. I know I haven't been in touch for a long time, but really good speaking to you or hearing you. But I grew up in Belgium, early 2000, and I think I spent quite some time in the pen testing atmosphere, the hacking sphere. As I mentioned before, I was teaching for SANS. I was helping people to get knowledge on how to break in. I was one of those pen testers that goes in, finds stuff, and then goes to the developer and says, "Hey, look at you! Like, this is not good. Your apps are bad." But I'll talk about that a little bit later. Now, today I basically live on the whole other side of the world. I live down in Australia, and I have to say it slowly because else people think I'm in Austria. But no, it's Australia. Basically, when you land here in Australia, the first thing you see in the airport is basically warnings that you should stay away from anything that it basically creeps and crawls and basically runs around here, because I think it's one of the only countries in the world where you can get killed by the smallest spiders and the smallest things that are in the sea. But anyways, I love it here. Now I'm kind of running a company which I started about 5 years ago. So I kind of went from being a very technical cybersecurity geek to now kind of spending most of my time looking at metrics and helping people and kind of growing my company. Now, why is this relevant to this talk? Well, in between, I basically had a lot of shitty code, a lot of bad code. Yes, I wrote really bad things if I look back to it now, saying, "Ooh, I should have never written that piece of code in PHP or in C# when I was in early 2004. But it's not only me writing bad code, it's also a lot of bad code that I've seen being written by others, whether it was students or whether it was people that were developing apps. And I think over the years, I've kind of tried to find ways on how I can make developers understand and think about security in a little different way. I probably don't need to tell this to most of you guys, but I think software is really shifting the world, or it's kind of powering the world. It's changing the way on how we basically live our lives. And it's not only the world, it's also the galaxy. Like we have satellites running on software. We have cars like Tesla and Neo kind of running on software. We've got microwaves, dishwashers, televisions. If you think about it around you in your house, there's so many things that are basically running software. And we roughly have about 25 million developers around this planet. I think that's the amount of inhabitants of Florida, or the whole state of Florida. Imagine that, like all of them are basically programmers around the world. And every single year, 1 million new ones are kind of joining the ranks of being a software engineer and kind of building code that is basically powering our lives and our critical infrastructures. In a perfect world, we should all have DevSecOps and build security into the whole development processes. We would have an SDLC. We would basically build security in from the start, in the design, in the architecture. Everything people write would be beautiful without any bad coding practice in it. We could then test it, and everything would be beautiful and nice. But unfortunately, today, security isn't really built into any development practices or even into any developer. If you look at the average developer when they graduate from college or when they do boot camps or they are self-taught, very often the first time they get confronted with security is when somebody kind of points out that there is shitty code being written and that there is some vulnerability that got detected by a scanner or a pen tester or any of that. So unfortunately for us, there isn't basically security isn't yet built into the developers or their tools or some of their processes. The other thing I've realized, and this is what I mentioned before, is that developers and security, they often don't play nice. And to be honest, I was one of them when I started out my career. As I said, I was doing penetration testing with a whole group of people, and we were not nice to developers, right? Like we basically took their applications, we tore it apart, we found weaknesses, problems, we broke in, stole data, got shells, pivoted, all that kind of, well, good or bad stuff. But then we kind of acted very arrogant about it as well, because we thought, oh, we know all these things and you basically don't. And very often the question came, well, how do we fix this? I'm writing, like the application is written in Node.js, and you found this XZ attack. How do you fix this? And I blanked because I was a security person. Like, I didn't know how to code. Like, yes, I can maybe do a bit of PHP and C++, the old language, but I've never experienced or worked with Node.js or with Rust or with any of those languages. Development security didn't really play us. And imagine this, right? You're a developer, you're building code, you built this beautiful baby, you worked for months on it with your colleagues, with your team. And when that baby is there, you want to get it out as soon as possible. You want to see how are users using the software that I've written. What impact can I have on society, on the world, with the new feature that we've just built? What happens is developers, they are so proud of their beautiful baby, and then security comes in, and security says, well, your baby is basically ugly because your baby has IDORs, XSEs, XSSs, and it's insecure. And we're going to say, no, you can't show your baby to the rest of the world. It's a really bad idea. Your baby is basically ugly. You shouldn't be showing it to anyone. You should first try and fix your ugliness of your baby. Developers ask, well, how do I fix it? And then the security people are saying, well, I don't know how to fix the ugliness in your baby. You have to figure that out. And that's kind of where what we've been doing roughly for the past 20 years, always pointing out problems. Whether you're a security tester or whether you're a security scanner, they behave the same way. Many scanners, depending if you use commercial ones or free ones, doesn't really matter. Many of them, they basically troll to code, they do testing, whether it's DAST or SAST, and they basically point out the problem and saying, here's ugliness of your baby. But none of them actually help the developer understand the problem or even understand how to fix it. And I think that's kind of where we ended up. The second problem that, again, I've been very guilty of is that I speak security and nobody else apart from security people speak security, because I use these acronyms of XSS, IDOR, XCZ, all that kind of stuff, and nobody understands it except for security people. we're using these terms in scanners and reports. We're bringing it up to management. Even the media starts using some of these. Like, I think my mom almost has heard of SQL injection. That's probably the only one, but these are security lingo that basically nobody else knows. And I think the same happens with developers. They are using a certain language. They are using acronyms that we really don't understand. And I think I'm pretty sure if you're a developer, you'll be looking at IDRA and saying, well, what is this? Oh, it's insecure direct object reference. And if you're a security people now watching this webinar, you're probably looking at the other one saying, IFFE, what does that mean? Well, it is developer language. It's a different language. And because we don't speak the same language of the developers, that is causing basically friction between those two groups. Another thing which I realized as well is that AppSec is heavily underrepresented in most organizations. Like, if I look at the customers that I work with, you might have one dedicated AppSec person for 500 developers, maybe for 1,000 developers. I've seen one for like 4,000. That means that person basically has maximum 1 day a year to spend with the developer to try and help them produce better code. So it's totally not scalable. So what happens is, in the world today where we have to do multiple releases a day, it needs to be agile. We basically have not only code, but we also have infrastructure as code. We have pipelines. We have new coding frameworks almost every single year. And AppSec is being asked to scan and test and help fix security of all of that. And as a result, AppSec hasn't really evolved as quickly as the development, and they're being squeezed. Like, most of the scanners are slow. They're not real time. They're not instant. Like, I haven't seen a security vulnerability scanner where you basically within milliseconds you have the results. No, it will usually take 15 minutes at best. It might take hours. Now, imagine that you're a developer, you're writing code, you want to get your baby and show it to the rest of the world as quickly as possible. But it will take you 4 or 5 hours to wait for the security results to kind of see it. And even if you see the results, half of the things in the report, they might be true, they might not both be true, because we have these problems with false positives and basically false negatives. So it's causing problems where AppSec is being basically squeezed and security is being a bottleneck. As a result, what we've been doing since very long is that we basically we write, or developers, they write code. We then bring in security testing, whether it's a tool, whether it's an expert, whether it's an external consultant, and these people, they identify flaws, and they are really good at finding the problems. Now, once the flaw has been identified, what happens is that a ticket gets created, whether you're using GitHub issues or using Bugzilla or using Jira. Basically, a ticket gets created because that's how that's their world, that's the developer world. And basically that ticket says, well, we've basically found a cross-site scripting vulnerability in this field, in this URL. We're going to assign it to a developer to basically go and fix it. The developer gets a ticket assigned. Everything goes well. The developer starts looking up, well, what is this thing? How can I basically remediate that in Node.js or in Java Spring? And that developer fixes the problem, and he or she then basically goes away and moves to the next ticket. Now, what just happened is that somebody in the organization caused a cross-site scripting vulnerability. Somebody else in the organization, or it might be the same person, they were assigned to fixing that vulnerability. Now, as a result, we have one person in the organization who now understands what is cross-site scripting and how can I prevent it. The challenge is that there are 999 other people in the organization that are writing software that still don't know what is cross-site scripting, that still don't know what is the coding pattern to prevent cross-site scripting. So what's been happening is that the next year, security testers, they find another cross-site scripting vulnerability, and they now found that vulnerability in a different part of the code. And basically that's a cycle we've been going through, because face it, be honest, cross-site scripting is an old vulnerability. Like, it should have lost all its hair by now as well, like me. It's basically early 2000, SQL injection, the exact same thing. Then if you look at XRF, And XCZ, well, these are all pre-2010 vulnerabilities. Like these are now teenager vulnerabilities. We should have gotten rid of them already. But the problem is, it's not. It's actually very common still today to basically find those. And I think it's because we haven't really helped the developer as a full brain in an organization to understand what these things basically are. One thing that I wanted to tell you as well is give you a bit of statistics around that, because I'm telling all these things, the theories that I've kind of made up over the years, but I actually have some data to kind of back that up. So I want to talk about common security bugs versus 100,000 developers. Now, before I show you some of the stats, I am going to give you a warning. The next 3 slides are screenshots of a vendor's product. And I know everybody hates seeing vendor products or pictures or name dropping of whatever in slides. So if you don't want to hear or see it, just close your eyes, close your ears for the next 60 seconds, and everything will be fine. What Secure Code Warrior, what we're basically trying to do is we're trying to build that brain capacity of security within developers. And what we've done is we've built an environment where developers can basically train themselves on coding patterns. And not by slideshows or videos, but really hands-on, practical in their own language. We then basically started integrating that into ticketing systems like Jira and GitHub and some of their developer tools. And this is just to quickly show you what happens so that you can understand how I collected all of this data. The developer logs in and they have to choose what is the language and framework you're basically coding in. Why is that important? Well, because if you look at vulnerabilities like cross-site scripting or SQL injection, they exist in almost every single language, but the way on how to fix these things is very different in languages, but also very different in frameworks of languages. So if you find a SQL injection in Java Enterprise and in Java Spring, like the way on how to fix these things is actually different. They're using different coding patterns. So that's why I thought it was important that a developer would actually choose what's the framework you use on a daily basis. And there are loads of coding languages out there, believe me. Like we started just focusing on Java. Now we had to support everything from Rust to COBOL, Swift to Android Java, because there's just so much code being written in different languages. Even C and C++ we started to focus on. So what we do, how we collected this data is that when developer logs in, they choose a language. We basically show them a live running application, and we basically want to figure out, does the developer understand what is an injection attack? Like, do they understand the impact? So we show them a live running app, we show them some code, and they basically need to kind of go through some exploring to figure out, well, A, what is a SQL injection attack? B, what is basically the impact of SQL injection attack? Now, I don't want to teach them to become hackers, to be honest. Like, that is the last thing that I want to do with developers. Like, it takes a lot of time, a lot of effort, a lot of focus, and most developers aren't really that passionate about security like we are. So I don't want to turn them into hackers. I don't want them to know how to exploit SQL injection, how to do SQL map, SQL Ninja, all that kind of stuff. No, I just want them to understand what the consequence will be if they are using raw queries versus something else. That's why we kind of show that. Now, the second thing that we're asking them to do is, hey, can you actually go into code and can you find out what caused this vulnerability? And once you figure that out, can you figure out how to fix it? So we're kind of trying to figure out practical ways if they can recognize vulnerabilities, understand them, and basically have coding patterns. So that's kind of, I thought that was more about 120 seconds, but at least that was a short introduction on how I collected data from roughly, I think, 100,000 developers that we've analyzed. Because they're all doing these challenges. They're doing it either in the training, they're doing it in the tournament, they're doing it when a security vulnerability gets assigned to them in Jira. There is a link there, they click on it, and as a result, they end up playing one of those exercises. And of course, while they're playing, I'm trying to kind of collect statistics about some of their, let's call it gameplay. Now, the first thing is, I looked at, well, what are the most played challenges that we basically have, or what is the most common vulnerability that's been played on the environment? Now, there's absolutely no surprises there. Like, the number one is, everybody is like SQL injection. is stopped there, and the rest of that list is pretty much in line with what you can see on just the OWASP 10. Like most people, they focus on whether it's vulnerable components or CSRF, but I think that the top ones are always like injection attacks, XSS, reflected and stored are the most played challenges. Now, what that means to me is that most people basically they either go to a training program that teaches that that basically shows them of these things, or they have scanners that are flagging these things as they're still vulnerable in your code. Ticket gets assigned, and that's kind of how they end up playing those challenges. The second thing is that I then looked at SQL injection. I said, well, if they're using the SQL injection missions, how many actually know what it is, and how many can identify the bad coding pattern? So do they understand SQL injection as a vulnerability? Now, I saw that there's roughly about more than 500,000 that basically have it correct, and that actually know that you shouldn't be using raw queries, and you should be careful of input sanitization and all that kind of stuff. And they understand SQL injection, so very positive. The negative side is that there's another roughly 35% that from the first time they get confronted with such a module, they basically don't understand what this thing is. They've never heard of it. They maybe read about it, but they can't identify the bad coding pattern of that in the code. Now, that is of course a bit alarming, because knowing that SQL injection is more than 20 years old, we should have really made sure people knew this when they're graduating, when they're doing boot camps, when they're learning about building software. Now, the positive thing is that you can actually help them. Like, if you show them the coding patterns on how to prevent this, if you help them understand the problem, and you show them, hey, you really should be using parameterized queries or mTable templates, or whatever language you're kind of using, then if you give them those coding patterns, they actually, there's roughly a 90% success rate that the next time they will write code or they look at code, they will know that this is the good way on how to talk to a database, and they will basically also start recognizing these faults in somebody else's code or in their own code. So that does mean that you can help developers by showing them coding patterns. Now, I'm not saying that you need to start writing coding patterns for every single vulnerability in every single language, but if you probably look around in your organization, depending on the size, you probably have 3 or 4 languages and frameworks that are most common or that are prevalent in your organization. So if you take those 4 languages and you take one vulnerability, the most common one that you find in your testing or your scanning, and you say, well, I'm going to take that one and I'm going to basically put that good coding pattern on how to prevent the vulnerability. I'm going to document it, or I'm going to send it. I'm going to show the developers that, hey guys, if you're doing this, you should be using this good coding pattern. You should be using this type of encryption. So you're kind of helping them with a secure coding pattern. And I think that's one of the things that a lot of security testers and security pen testers, including myself, have not done properly in the past. If you ask the average pen tester saying, hey, how do you fix SQL injection? What's the default response? Input validation. Now, input validation is something that doesn't tell the developer anything. They have no idea what do you mean input validation, input sanitization, what function, what library, how do I do it? And that's where I think security testers can really help the developers becoming better by, when you do pen testing, like show them the actual coding pattern that will fix this problem in their framework. And they will absolutely love you for that, because you've just saved them time. They can close that security ticket way more quicker than anything else. So if you could kind of bring that into ticketing systems, saying SQL injection, here's a coding pattern that you can use, that would be absolutely fantastic. Now, looking at some of the other stats coming out of that, IDOR, insecure direct object reference, a very common vulnerability being used to kind of extract and find data of other people. There's a roughly 45% success rate, which is a bit sad. And the same with things like even cross-site scripting is roughly about a 50% success rate when they first play or when they first get confronted with code that has that vulnerability in there. And I really wish that it was different. I really wish we could bring this up much higher. The other thing I've kind of tried to analyze in the data is that because we have like 50 different languages and frameworks, I wanted to figure out, is there a difference between security and developers that are using different languages. Like, do you code worse in Java Enterprise if you're a Java Enterprise developer than if you do Java Spring? And what came out is that the developers that are choosing Rust as a language in our platform, that they are basically having a 98% accuracy. That means that Rust developers, I'm not sure it's because they are security conscious that they choose for Rust, or basically, but they are making way less mistakes in these type of security vulnerabilities. So Rust being one, PowerShell is a bit of a weird one. Why that's kind of showing up in our statistics, but I think it has to do with infrastructure as code, which kind of now starts using some of these languages. But also things like JavaScript and Go API and Kotlin were kind of coming up as in these languages, there are the least mistakes being made from a security perspective. So the security, the developers that are using these languages, you could kind of assume that they are more aware about security. Then I looked at the other side, like what are the languages where you find the developers that haven't really understood security very, very well. And I think there, COBOL, yes, you'll be surprised, but COBOL is still there. If you want to make a lot of money, I would highly suggest you start specializing in COBOL, because I think COBOL developers are either at the end of their retirement or they're just not here anymore. And it's really hard to find really good COBOL people. Now, let alone finding COBOL people that know about security. So we kind of popped up that COBOL is basically one of the languages where the developer isn't security trained or security minded. Yet the same with CBasic, PLSQL, Java Enterprise, and Java Struts. And those last two were really surprising to me, that even Java Enterprise, something that is used in a lot of organizations, actually has not so good scores on our platform. Now, what are some of the top 5 most understood vulnerabilities, which means that developers that are getting confronted with these missions, what do they know basically best? Well, things like server-side request forgery, which is, I wouldn't say recently, but it is, versus SQL injection, it's more recent. There's actually a good understanding about that vulnerability. The same thing around XSE or rate limiting. Those are like vulnerabilities that developers actually understand. What are the least understood? And there's no surprises there that business logic is the lowest, because business logic is one of those vulnerabilities that could be anything, because it's related to how your application is function, what it's actually performing. So there's no real coding pattern that you can identify or can learn to kind of stop business logic vulnerabilities. It's all about understanding what the application does. So that's the one that kind of pops out as saying, hey, most people are making mistakes in that area. CSRF or CSRF, really, like that should be fairly simple to understand and fairly simple to fix in most of the languages. And even things like denial of service and preventing that is, I would assume that people could understand that better. One statistic I also pulled out, I looked at those 100,000 developers and said, well, which developer here has spent most time kind of training and helping themselves understanding security? And we had one that completed about 3,000 of those exercises, roughly in about 108 hours. And we had one developer that spent about 133 hours on the platform. And spending that time on the platform, we measured in a way that you're actually actively engaging with the different sessions. It's not that you just surf to the website and starts measuring. So that's where I got 2 security champions that I've kind of or at least very passionate about security that I've kind of pulled out, which is also very useful data for you to know that if you basically have 1,000 developers, you want to find out who are the ones that show most interest. They might not be the most skilled one, they might not be the most knowledgeable one in security, but who is showing the most passion for the subject, because they could be a great addition to your AppSec team, or they could be a great security champion or advocate for you in the developer community. What basically happens when basically developers, when you've kind of pushed them and helped them and given them coding patterns, or even taught them about what are your top 3 vulnerabilities? I kind of pulled out a statistic from, there were about a group of 5,000 developers, and what we've done is in the platform, we kind of put up, and I know this is going to sound bad, but we've put up a kind of a test of a certification. We basically said, well, there's basically 3 levels. You can get yourself a white belt, and in the white belt, what we do is we test you whether you have the knowledge of the top 3 key vulnerabilities that are happening in your group. So we basically took 3, and that data, you can take it from your SAST, from your bug bounties, from your pen testing. You just take data and you say, well, these are the 3 ones. And if you can demonstrate, you know how to fix these things in your specific language, you basically pass that assessment. We also built a white and a yellow and an orange belt, which of course makes things a little bit harder, and we kind of focus more on the OWASP top 10, but also beyond the OWASP top 10, because many people don't understand that there's also a beyond OWASP top 10. OWASP top 10 is not every vulnerability. There's at least 40 to 50 more, which also could be very prevalent in the organization. So we kind of built this belting model, and then we basically asked developers to kind of take the assessment. And you can see some of the results. 70% basically they passed that assessment, and there were 15% which I think didn't really take the effort or didn't have time to kind of spend on this thing. And what we saw, that we had about 20 events we run over 3 years. They spent in total about 13 years starting to understand. Remember, these are 5,000 developers. 13 years, they basically started to trying to understand security. And I think as a result, what we could see is that those top 3 vulnerabilities that we've selected in our assessment is that in the next few months, when they were writing code, they were basically that number that was being detected by these scanners or pen testing or in Jira tickets actually significantly decreased over time. Because now you've basically given the knowledge to the developer on how to recognize this, how to kind of prevent this. And you don't need to teach them about every single vulnerability. If you just focus on the 1 or the 2 that are continuously coming back. And I know, like, if you look at your scanning results the past 5 to 10 years, you will see a recurring, repeating pattern. Like, there is no way that you basically have vulnerabilities that are not recurring. Most vulnerabilities that we see are recurring because of the thing that I've explained you earlier, where the knowledge is usually with 1 or 2 developers and everyone else doesn't know about this. So, but if you take an approach like that, if you build the coding patterns for the top 3 vulnerabilities and you show them, it doesn't matter how you do it, whether you use on internet or awareness sessions or manual trainings or how you kind of try to do this, you can actually achieve a significant improvement by, for example, eradicating things like SQL injection, which should have been eradicated, honestly, 10 years ago. So that is a really great achievement by just focusing on awareness and kind of helping those developers. I'm almost at the end. One of the things we as security need to do is we need to try and make our developers superheroes, because they are writing code. They don't want to be slowed down. We need to help them to speed up and to basically enable them and go fast and not be security that is holding them back or slowing them down. And I think you can do that by trying to put your mind in a developer, like go into their world and try to understand which tools they're using, how they're using it, what the pace is, how they're looking at code, and where you can kind of best help them. As a conclusion, if you actually want to make the baby pretty, first thing is you can try and integrate security into their IDE, whether it's writing specific linting rules, whether you want to use some of the commercial plugins that exist or even some of the free plugins that exist. If you can bring security into their IDE, well, that is at least if they're using an IDE, but if they are, you bring it into the IDE and you can actually help them prevent these vulnerabilities from being written in the first place. Now, you have to be careful. What you don't want to do is install a tool that gets pushed by security that is going to cause delays, or that's going to cause the developer to get frustrated because it's popping up a flag saying this code is vulnerable and it's actually not vulnerable. So be very careful by evaluating, is this the right tool? Is this the right way on how to put security in the IDE? And if it's not, if you are going to have something that's going to pop up bells and whistles and stop them and block them, then I would say don't go that direction, because be very careful with the relationship and the friction you are creating with your developers. And even if it's installing an IDE plugin or a linter that has one rule and one rule only, and that is to kind of prevent SQL injection, you've just eliminated a full class of vulnerabilities for anyone that is using an IDE. So it's a really effective way on how to try and eliminate certain classes of vulnerabilities. The second tip that I could give is that if you can't build it into the IDE, the next best step is to try and build it into their code repos or into their pipelines. Same rules apply there. If you're going to install something in their pipeline, or you're going to suggest to install something in the pipeline, make sure it doesn't block, it doesn't unnecessarily flag things. Make sure it is fast and it is reliable. And even if that means you need to focus on 1 or 2 vulnerabilities only, except on the 5,000 that exist, well, only focus on 1 or 2, because it's way better to eliminate 1 or 2 vulnerabilities than to basically start annoying and slowing down the pipeline. Third thing is that one thing that I'm a big fan of is that define the secure coding patterns, like know what vulnerabilities exist in the organization. If you find them in your testing and your scanning, just define how can I prevent writing these things? What library do we as an organization suggest? And it might be best practice. You might use somebody else's library. You might basically use or write your own libraries to make things safe, but give them something that they can work with so that the developer understands you are not the security person that is just pointing out ugliness in my baby. You're actually kind of trying to help me understand and stop these vulnerabilities. And then the last thing, or the last 2 things, is that integrating knowledge and bug trackers, I think, works really well, because sometimes sending developers to a location to say, hey, if you've got some spare time, go and read basically on security guidelines and practices. Well, developers don't have a lot of free time, right? And if they have free time, they probably don't want to spend it reading on security guidelines practices. So what if you can just take knowledge, or you can take your coding patterns that you've defined, and you can directly integrate it into their ticketing system. So when a security ticket gets assigned, you basically write your own scripts to attach a link to your page where you store those coding patterns, saying, hey, this vulnerability is about cross-site scripting, and here's a coding pattern that you can use to fix this thing. It saves them time. It gives them the exact correct answer, because if you don't do that, most developers are going to start using Google and say how to prevent this kind of an attack. They end up on a developer forum, might be Stack Overflow or something else, and they will start copy-pasting coding patterns from other people that you don't know, that you don't control, and very often might contain extra vulnerabilities or other nastiness as well. So it's better that instead of using Google, why don't they use the library or the coding pattern that you basically started defining? And the last thing, and I think this is the one that can really make a difference, is that make security something positive. Make it not scary, make it fun, make it engaging, make it smart, make them feel that you really care about them and helping them to produce better code, and do it in a positive way, rather than basically going in and basically pointing out every single ugliness in the baby. I'm not sure how I went in time. I said this is a first presenting on my mobile phone. I feel like I've been talking to a wall for basically 40 minutes, because you get no interaction at all of the audience, which is a bit weird. But anyways, I hope this was useful, guys.
It is extraordinarily difficult, even when you have a screen up with everybody's face and everything. It's still really hard to feel like you're getting your ideas across in any way, with no body language, no people falling asleep in the back, no people asking voice questions. I've done a couple of trainings now online, and it is exhausting and demanding, and I know exactly what you're talking about.
Yeah, I like, in my head, I imagine an audience which is now just all sleeping, or an audience that might have laughed on your jokes, or might have not, and think, what is this for a stupid joke, or might not even understand your funny accent. So I have no idea, and it's a bit hard.
So I have a project right now where I'm doing a lot of what you talked about in your talk. That integration into IDE idea, that concept is super powerful, but you run the risk of overwhelming your developers. Depending upon the tools you're using to do the analysis you're doing, you end up with sometimes a lot of non-actionable things. Well, what do you think about putting things in place to triage that data that gets filtered to the developers via their IDE?
If it's causing too much noise, it's better to not do it. Let's face it. Like it's better to basically not annoy or pop up or do anything. I like the idea of triaging, but you're causing a delay, right? Like somebody is writing code, and at that point in time, they basically wanna fix syntax errors, they wanna fix bugs. They don't really care whether it's a security bug or any bug. They just want to know, hey, is my code good to go? Can I commit it? Can I submit it and get into the master branch? So if you're causing a delay there, it's not ideal, but it's better than, I think, flagging too many things or yeah. That's my opinion, at least.
Makes sense. A lot of people have chimed in on the chat saying, we're awake, we're laughing at your jokes, we swear, you've got a great accent. I think you ought to just redo the whole talk in Dutch, personally. I mean, it wouldn't take that long, right? Dutch is a fast language. Somebody pointed out that they kept realizing why my boss behaves the way he does, makes the decisions that he makes after listening to your talk. So that's some pretty good stuff there. You talked about using pipeline tools, and that was a research topic of mine last year, was the software supply chain, which is accidentally became a really big topic because of SolarWinds. And I was wondering if you dug into it all, like the tools that, say, for instance, GitHub is providing on the supply chain side. Like it's very funny with OWASP. I log into the Columbus chapter website, and I get an error at the top of my screen that says, you're using an out-of-date component. Well, I'm not using any component. That's somebody else's decision that put that component in place. And it's very interesting to see how that, I don't know, that interaction occurs where you've got multiple developers on a single project and somebody else makes a decision that impacts you. I was wondering if you run into that at all in the supply chain piece.
I actually am really interested in hearing your research conclusions on building security into the pipeline. But I think one of the things that, for example, GitHub is doing great. What I see in the pipeline is that if you have one language or framework, like you're using Java Spring, you can find tools that can handle this into the pipeline. But if you're using 20 or 30 languages, at the moment, there is not a tool that supports all of that. And I think what GitHub is doing is with GitHub Actions, where you can actually make decisions based upon the code that's been submitted, the language that's been submitted. You can call on different actions. You can call scanner A here, you can call the scanner B there, scanner C there, depending on your the code that's been committed. I think that's probably very promising. I know it's only it's the whole GitHub Advanced Security thing is fairly recent, but I think it's very promising. But I haven't seen in an organization like a state-of-the-art good implementation of building tools into the pipeline, as if they're using multiple languages. If it's only single framework organizations, then it's easier. But if you use multiple languages and framework, it's really hard to get that done right, I think. But what did you find when you were doing the research?
Well, my research was largely around the package managers. So you go to install SQLite using npm and it brings in 112 packages or whatever. Who's doing the static code analysis on those packages? Is anyone looking at them? Is anyone comparing the configuration files to what the standards are for your organization? Probably not. So that's something a little bit harder for like GitHub to do. So if I build a product, use npm to pull in various and sundry libraries, and they pull in their libraries, and they pull in their libraries, and I've got all this big block of code to do this one simple thing. GitHub doesn't know what my organization's standards are. So all they can do is say, hey, this component's out of date. Well, that's probably not the case because I just ran npm. So under certain circumstances, they find things like, under certain circumstances, they find things like, encoding problems or encryption problems or pieces like that. But mostly they're looking for out-of-date packages, which is certainly worth doing. But the reliance on standing on the shoulders of giants has become a really big problem, and that's kind of where my research went out there. I think I was recorded giving the talk somewhere. If you're like really bored and can't sleep one day, you can look it up on YouTube. It's called Snips and Snails and Puppy Dog Tales is the name of the talk, and it was some really interesting research. Then all of a sudden it became really appropriate when SolarWinds came up. So
yeah.
So lots of people saying awesome job, Peter. Thank you so very much for coming in and talking to us. This was really fascinating.